Thank you. Folks, good morning and good afternoon again. Uh, Let me know if you all can still hear me okay and see the screen that I'm sharing.
Yes, Muthu, we can see.
Okay, very good. Okay. So this is, sort of a continuing on the theme that, we started a few weeks ago, right, on the, networking services offered by AWS, and Route 53 is one of the important service that AWS offers to us. So in this session, we will have a sort of a primer on DNS because Route 53 is primarily a domain name system based service, and it really would help to have that primer, I thought. Unless you're all familiar with DNS as a concept, we can skip that section. I have few slides on that in case if you have to level set. So let me know if you're all interested in seeing that, uh, or else we'll skip that DNS service introduction. So this is the agenda for today. So once we are done with the primer and DNS, then we will drill down on the AWS Route 53 service. But again, I heard some of you, say that you have some understanding of AWS as a service offering that AWS provides, right? So if in case if you are slightly new to AWS, this may not be a good starting point. Uh, Sorry about that, but it's what it is, right? So, in case if you have some background on, in general on DNS, I'm sure you'll be able to pick it up and understand what Route 53 services. Uh, that should be fine. You don't need to have a prior AWS expertise, but in case if you have any other questions on basic AWS service or DNS in general, we'll try to address, or else we'll park it, outside of this discussion. So we will spend most of the time on the Route 53 service by providing you all an overview of exactly what its offerings are, what are the various features it provides, unique features, so to say, that you would not see otherwise in other DNS service that are offered by other providers. And we'll round it off with the demo of Route 53 service. So again, does it help to provide you all a overview about DNS, or we can skip that section? I just want to take a quick poll.
Just do quick 2 minutes so introduction.
Okay.
Yeah,
Yeah.
yeah.
Yeah. I'm not sure if I can do it in 2 minutes, but probably 5 minutes or so. Yeah. So the domain name system, as we all know, is a service that is being used. You know it or not, even people who are just a simple internet users, right, are using that service, knowing or unknowingly. When people say, "Hey, I want to go to Google site," right? So they will go to www.google.com. That's all they will know. They don't know exactly what happens in the background, right? So we all know we have the IP addresses, the routable IP addresses v4 or v6 that are very difficult to memorize and remember for all the different internet servers or internet websites that we have. So that mapping is being provided, uh, to a human understandable domain name to an IP address mapping is what is provided by the DNS service inherently, uh, which is a very important glue in the way how we all know and how we just take it for granted, right? So in the internet, it just simply works. So the way it works is by organizing all the infrastructure in a hierarchical way, right? In a tree structure. If you see this particular diagram, it shows how the DNS system hierarchy is set up, starting with it's a tree diagram upside down, meaning the root is at the top, right? So we always start at the root level domain, and underneath that there are many top level domains, what are called as top level domains. You have the .gov, .org, .com, even countries. There is a 2-letter ISO code, right? That's also sort of mapped to a top level domain. So we start at the root level, and then we go to what is called as a TLD, or the top level domain, which is um, kind of mapped to one of the known domains, or mapped to a 2-letter ISO country code. Then underneath that, you will have the specific domains. For example, under uh, .com, you have AWS.com, or sorry, not AWS, Amazon.com, or a Google.com, or whatever website that you want to go under that, right? So, and you can have subdomains underneath that. So all this, you know, are all mapped to this domain system, domain name system infrastructure in a hierarchical way. So whenever you say, I want to go to www.google.com, what happens in the background is, you have, let's say you're trying that from your laptop or your desktop. You have to configure what is called as a DNS resolver or a DNS server on your client workstation or a client laptop or anything. So that laptop, if it has cache that information. For example, we'll consider the scenario of non-caching scenario. The first time you're booting the laptop and you're trying to go to google.com, it sure will not have that mapping cached in that laptop or a endpoint or a workstation. It will not have the IP address that corresponds to the www.google.com server or host in the internet. So it has to use um, it has to use the DNS protocol to find out the mapping for that particular domain name, and it has to get the IP address and provide it to the browser, and only then the browser can connect to the server. So to be able to do that, what it does is it contacts the root level server, and the root level servers would say that, okay, hey, you're trying to go to www.google.com, which happens to fall under .com top level domain. I will give you the, you know, a name server, domain name server that can provide you that information. And that's all the root level servers will. The root level servers will point them to the specific top level domain. And that reply would be used by your DNS resolver to query the .com level top level servers to find out, if it can help you to provide who's the name server for google.com. And it recursively, you know queries and goes to the name server that can provide the authoritative information for the host that has a name called www, and it provides the IP address. So that's how, in a nutshell, the DNS works. And I'll just show I'll quickly skip some of the slides, and we'll come back to this if need be. So this slide sort of summarizes exactly what I was talking about earlier. So let's say you have an end user is trying to go to www.google.com. In this slide, it shows us an example.com. It doesn't matter, right? So this end user for the first time is trying to go to this domain name from its browser. And let's assume this is the first time this end user is trying to find the mapping, or tries to go to this website and doesn't have the information cached in its system. So what it does is it uses the DNS resolver that is configured on the endpoint. Typically, the DNS resolver, if you happen to be working from your home, and if you're using a service provider, the service provider would probably give you a DNS server, or you can change to any DNS server. There are a lot of you know DNS service, free DNS service that are being provided by, like, even Google, or even Cisco has Umbrella or Open DNS server, and there are a lot of other companies that provides too. Or if you happen to be in your company, or in your enterprise organization, they would have set up a DNS server, and your client would be configured to use that. So essentially, the endpoint has to use a DNS resolver or a DNS server to be able to query that and get that information. The DNS resolver itself may or may not have this information readily available. If it has, uh, it would have cached it from some other query that came to the DNS resolver from some other user, and it would readily provide that. And every record has notion of a time to live as well. So in case if the time to live values are reached, then the server has to invalidate, and it would let that expire also. In this case, let's say the DNS resolver doesn't have this information, then what it's going to do is it's going to contact the root level server. So this is at the DNS hierarchy, we saw the server at the top of the tree. So the DNS resolver is going to say, hey, root server, can you give me the mapping for www.example.com? And the root DNS server would say, oh, okay, so you're trying to find the mapping for the server, but I'm a root server. I cannot, provide you this level of information, but I can tell you who you can go to get this information, and it gives the top level domain, name service for the .com domains, and that's the query that it replies with. The DNS resolver, it takes that information back, and it goes to the top level domain for .com and says, can you give me the mapping for this example.com, www.example.com, and TLD is going to say, okay, I can't provide that information, but I can give you the authoritative name server for example.com who can provide that. And that's how the DNS resolver would find out the name server for example.com, which can provide an authoritative answer for www.example.com. And if you can see in step number 5, the DNS resolver would send a pointed DNS request now to the authoritative name server for example.com domain. And that may or may not be in AWS. It could be hosted in your own private DNS server. It could be hosted by some other DNS providers like a GoDaddy, or it could be anybody. And that server is the one which can provide an authoritative answer, and it provides that with the mapping of 192.0.2.44, which in turn the DNS resolver caches it if it doesn't have, and then it provides it to the end client, and the end client then actually can make the TCP connection. So far, all the connections that we saw, it's all happening through UDP protocol on port 53, and that's one of the reasons why it's called Route 53 uh, uh, in AWS, right? If you see why the genesis of why they gave this name as Route 53, it uses 53 as a UDP port 53, right? And it's a DNS-based service, and it helps you to find the route. Uh, so that's in a nutshell. I just wanted to. I have more, details on, what is recursive versus iterative and things like that. So if you guys, want, you can just spend some time and you can review that. I'll be happy to go over it if you have time after we go through the Route 53 service, right? So I'll skip for now all the slides. Any questions on, how this DNS service works in general before we jump into the Route 53 in particular? All right. I hope it's clear, and we'll quickly jump on to the Route 53 service. So as I said, Route 53 uh, is one of the very important network service that AWS provides, and it's being provided through the global infrastructure that AWS built as across multiple regions, so to say, right? Even within the regions, there are dozens of sites that AWS has, and this particular service, Route 53 service, is being provided from all those different locations. That's one of the reasons why I think we may have briefly talked about some service being global and some service being region specific. Route 53 is a global service, meaning you just configure Route 53 from one place, and it's going to be available from all the different regions in the AWS infrastructure. That's why it's called as a global service. And it uses anycast infrastructure. Uh, Again, a lot of jargons here, so I'm guessing that you all are familiar with the term anycast. If not, it's not a big deal. Typically, uh, when you need to have communication between devices, you configure it with an IP address, right? So um, IP address, can be of many type. It could be of a type whereby you just configure a device with a unique IP address. Uh, so in that case, we tend to call it as an unicast IP address, meaning if you try to address that particular IP address, only one host is going to respond, and that's a unicast address. Anycast address means you can configure the same IP address for multiple devices in your network. There would be no duplication, but when you try to reach that particular device using that IP address, the device which is geographically closer to you, metrically geographically closer to you, is the one which is going to respond. What it provides you is a sort of a resilient or a redundant infrastructure whereby you can configure a host to be present in multiple location, and you can configure the devices to provide the same services, and that provides you some sense of you know of some kind of resiliency towards failure, so to say, right? So that's called anycast IP address, meaning you configure the same IP address for multiple devices, and you start to use that service, and whichever the device that are closer to the end user or endpoint which is trying to use the service would respond to that. So that the AWS service, the Route 53 service, uses anycast infrastructure. Meaning you configure something that gets replicated to the whole of the global infrastructure, and whichever site that your end users are closer to, irrespective of the geography, right? So you will have availability provided by the Route 53 service. And one of the very important feature that Route 53 provides compared to the other DNS service are the unique set of routing capabilities that it provides. So typically, if you see the DNS service, they would probably be offering simple routing or a round robin based, um, uh, you know, uh, a name lookup. But Route 53 offers a rich set of features, over and beyond simple and round robin, which is, sort of a multi answer. We'll see that in the upcoming slide. It also provides failover based, low latency based, geolocation based. We'll see exactly what those are, and in what scenario or use cases you can leverage that. So, and one other important thing is AWS Route 53 not only provides a global DNS infrastructure, but it also sort of acts as a registrar, right? So registrar are the companies where you go and register your domain names, right? So uh, like GoDaddy and other companies. So AWS provides a one-stop shop whereby you can just go register your domain. If it's available, they can actually act as a registrar, and also they can act as your domain name service provider. And it works well with other AWS services, meaning it organically gets integrated with other AWS services, such as your ELB Elastic Load Balancer, or with CloudWatch, and all other services, which helps you to you know uh, perform health monitoring, and quickly act on if there are any failures. It can actually quickly switch the record sets and things like that. And as always, AWS provides multiple ways to configure and manage the service. You could do that using the console, or you could do that through CLI or SDK. So
Muthu, can we
there are
stop here
primarily.
and ask if people have some question?
Sure. Yeah, of course. Yeah. Thanks, Kanak. Yeah. Any questions, folks? I hope we have not lost you all because this is something that if you're slightly new to this, right? So especially if you're not dealing with infrastructure and things like that, this maybe slightly a new topic for you all. So, but feel free to ask any questions if you have. We'll try to answer them.
Muthu, just before going this, as a infrastructure developer, how much people have to deal with this, and how it will be useful? I know the answer, but I just want asking for others so that they know when they would
Sure.
exactly need to use or at least know about this Route 53.
Okay. Yeah. Thanks, Kanak, for that question. It's a good question. So I'll take a simple example, and probably it's one of the features that AWS provides, and probably we can build on that. Let's say you are in an application developer, or you could be a person who's responsible for setting up the infrastructure to offer that service. So let's say you're a company is asking you to set up a web server in, let's say, two different data centers to make sure that you don't have a single point of failure, and you have to offer redundancy and things like that, or maybe you may have to load balance and all those things, right? So you uh, as a person who's responsible for that, you probably would say, hey, I'm going to throw one server in data center one, I'm going to throw the second server in data center two, and make sure I set up my applications, and um, somehow magically it has to work, right? So again, uh, in these days and age, right, we have very clearly marked responsibilities. Some people would say, hey, I don't do that, that's not my job. But in some organization, some people have to do multiple things, right? So let's assume that this is for a scenario whereby a person has to do everything, right? So now they go and install the server in two different locations, two different data centers, right? That may or may not be in on-prem, that may be in cloud, or it could be one of them could be in a cloud, the other one could be in an on-prem environment. So now what you have to do is you have to think about propagating this information out to the internet, right? So how would you let your customers know that you have two servers that can be used to access the service, and what those IP addresses are configured with those two servers, and let's say you primarily want to configure one of them as a primary, and the other one should be used in case the primary is not reachable, or if it fails, right? So let's say that's a scenario. So uh, what Route 53 would help you to do is, after you install your server, deploy your server, you just have to take those IP address, assuming that the Route 53, you're using Route 53 for your domain name service. You just have to go there and create an address record, and you would configure one of them as a primary. In this case, instance one, your maybe it's in in your cloud provider. You want to have that as a primary server. You will take the IP address of the service, or the server that's running in the cloud, and configure in the Amazon Route 53 AWS DNS service as a primary DNS server. Let's say it's a www.example.com, right? So that's your domain. So you would create a record set, and designate that as a primary record set. And the way you do that is you have to configure what is called as a health check. So only if the health check passes, the health check can be done using multiple ways. You could simply say if the server is reachable, or you could just check to see if your website is running on a particular path and all those things. You could do different levels of health check done. So when you designate a server as a primary, when you create a DNS record, you have to do the health check. You have to configure the health check, and you have to tie it to that. So that's how you do that. And similarly, you have to configure a second resource or a second server. But in this case, now you would use the same record set name. You would use the same www.example.com record set, but you will configure that as a secondary server or a failover server. And that's how they are paired together. So again, sorry for the long-winded answer. I hope that kind of gives some context as to how this is become relevant to people. You may be a developer, or you may be an infrastructure person, how this is going to tie to the big picture, right? As to just trying to make sense of um, how the Route 53 service is going to help to solve the problem that you have at hand. Uh, I hope that kind of shines some light and shed some more additional detail as to where things fit in. Uh,
Yeah, so basically, if you're starting a startup, let's say there is a startup, you're putting like 100 instance on one VPC, another 100 instance on VPC, then setting up your application, then the load balancer for your application, and then the next step is like you need to let the people on the outside the world, outside the AWS, outside the internet, so they need to access your application, use your application. So that's when you need to have a DNS domain. So you register DNS domain with your company name. AWS Route 53 service offers that registration for your DNS domain. And then you put your load balancer, I mean, what are the application, the outside the load balancer to the world, you tie to a DNS service, which Route 53 would help you to do that. Is that
Correct.
right?
Yeah.
Okay.
Very well said and very well connected.
Okay.
Yeah.
So let
Probably
me
I kind
ask
of, yeah.
one more question, Muthu.
Mhm.
So when you create instances, let's say you create 100 instances within a VPC in a data center in a location, AWS,
Mhm.
right?
Mhm.
Sorry. And you put private IP addresses to all your instances, and every instance will have its own DNS name, right? Something Amazon, AWS kind of name, right?
Correct.
Okay. Then this Route 53 required the Route 53 service that basically you need a DNS server for outside world. Okay. Inside you have inside you may not need it. Let's say when you're connecting from instance to instance, you don't need it, right?
Right. That's
Okay.
right.
It's mainly for outside folks. Like you create everything, you set up your infrastructure, then you want your customer to use your website. So that's when the Route 53 is critical if you are managing everything by yourself.
Correct. That's correct. So just to shed some more additional detail, let me know if you all can see this screen that I'm sharing.
We can see the console. Yeah.
You can see the console, right? So give me a minute. So
Yeah, on
may
the right
time out,
side
and
you have a
yeah, yeah. So it may time out, and I may have to. Okay, let's see. Okay, it hasn't timed out. Good. Okay. So what I have done is I have actually spun up a EC2 instance, right? And this is just to expand on what Kanak was saying, right? So by default, whenever you spin an instance, not only you will get a private address, but by default you will get a public IP address also. Again, this behavior can be changed you can actually, when you spin up the instance, you can say, hey, don't bother assigning me a public IP address. You could say that as well. But the default behavior is you will get a public IP address as well, along with the publicly reachable DNS name as well, right? So now, going back to the example again, Kanak gave, let's say you have your own startup, and now you want to register a domain name or a DNS name for your own company, and you want to map that EC2 instance to that domain name. So again, you could do that in two ways. One, you simply take this public IP address, right? And let's say your startup, it's called mystartup.com. So you call it as, let's say you're running a web service on this server, and you want to be called that as a www.mystartup.com. Assuming that mystartup.com domain name is registered either in Route 53 DNS or somewhere else, all you would do is take this IP address and create a record set called as an A record, address record, and give it a name, www, and provide this IP address. So that's one way to do it. Second way is, you can use what is called as alias, right? You can use C name or alias, canonical name or an alias. So again, I didn't want to, we'll see that in detail. So you can actually set up what is called as a record of type alias or a C name, and you can use a resolvable domain name. In this case, let's say EC2-3-80, whatever. So this is a domain name. You could create what is called as the alias or a CNAME record, and you can point it to this as well instead of using an IP address. So I just wanted to give that additional detail. We'll be covering that in one of the slide as well, but uh, I just wanted to add
Yeah,
that.
I hope that's clear for people to understand why the Route 53 even required when you're setting up environment in AWS. So if anybody has a question, we can answer here, or then if not, move ahead with the next slide.
Yeah, I have a very quick question, Muthuraja. Can I? Do you have a minute?
Please go ahead. Yeah.
Yeah, I'm very beginner here, so I have one basic question here on Route 53, so if you're going to have, so the public IP address of the specific EC2 instance, when it's going to roll over, so it is going to create a new EC2 instance, that time IP address might get changed. How that routing happens in that case?
Okay, so I want to make sure I understood the question. So your question is, let me use the same slide again. So
Correct.
you have set up an in your let's assume that you have a registered domain, and in that registered domain you have a www. Let's say you have a address record, okay, a record. We call it as a record. That's pointing to instance one. Okay, well, let's say this is your web server, www.mystartup.com. Okay.
Yes.
Now this user is trying to reach that, and Route 53 provides the mapping for that record, and it provides the IP address associated with this instance. Now this fails, right? Now you want to know how it's going to fail over to this, and how the user would be provided with the IP address associated with instance 2. Is that your question? I want to make sure
It's not. So I'm asking, so I have a, so website hosted in EC2 instances, more than one instances. So, so when scaling up and scaling down, some of the instances will go down and new instance will coming up, right? When the new instance comes up, how that joins and that, routing configuring.
Okay, I get it. Okay. So your question is more like, let's say I have a load balancer in front of these two. It's not a primary failover situation. I have a load balancer, right?
Yes.
I'm essentially load balancing bunch of servers fronted by a load balancer, and the number of servers may grow up and down. It could grow, it could scale out or it could scale in. and how would the user would you know would know whether it's dealing with the server 1 or server 2, or if I understand right, you're curious as to how the Route 53 service is going to help in this case, right?
Or I
So
think it's a load balancer question, right?
yeah, and the load balancer and Route 53 uh, integrates with multiple servers, right? So one of them is a ELB. It works well with the ELB. So in this case, what you would do is you would create what is called as a alias record, right? So when you go to the Route 53, you would create an address record, and you would say, hey, I want to create an alias record. So the alias record would not point to an IP address. It would instead point to, as I said, in the screen, right? So when you create a ELB, right, the ELB also would get a publicly resolvable DNS name, right? So let me see if I can show you.
Muthu, can you explain what is ELB?
Yeah, it's the elastic load balancer, right? So now I kind of switched to a different screen. This is a domain that Aru owns. So I'm on a different account now. So let's say I'm in the Route 53 dashboard, right? So okay. So again, going back to the uh, question Aru said, what is an ELB, right? So everybody knows what is ELB, or you want me to quickly spend a minute and explain what is ELB?
Yeah, Muthu, you can explain that also.
Okay, 1 minute. So we did cover this in one of the past sessions. So I'm just pulling up the slide, right? Give me a minute. Okay, so probably I'll just use this slide, right? So let's say you have set up a bunch of servers in AWS, or it could be AWS, or it could be on your prem as well, on your on-prem. So let's say you have a bunch of servers. We can see that there are 10 servers that are deployed here, right? You can see that 4 plus 4 plus 2, right? So if you don't have a load balancer, right, how would you route all your user traffic from the internet to all the 10 servers? How would you do that? It's just a question. So it's a simple question. So can you guys try and see if you can answer, or just think through that, how you have to do it? It can be done in multiple ways. A simple way to do that
Yes,
is,
so basically a kind of proxy. The load balancer would act as a proxy for all
let's say
your
you don't have
external
a load balancer. Let's say, I think the question is for people to think how they can solve this without a load balancer. You can solve this problem without load balancer as well, but it's a kludgy solution, right? You can actually use a DNS to provide multi-value answer, meaning you have to set up 10 different A records. It's a kludgy way. You can solve the problem, but where Kanag is going is use what is called as a proxy, or rather a reverse proxy, or a load balancer. Okay, so this icon, right, that shows a load balancer. The load balancer is an application, right, which would be used as a single port of entry for all the 10 servers in this case, right? In this example shows that there are 2 load balancers, but just ignore the fact that you have 2 load balancer. Let's assume that there is one single load balancer, and behind the load balancer, you have all the 10 servers. So when you configure the load balancer, you have to configure what are your targets. So you have to define your targets, saying, okay, I have 10 different targets. But from the client's perspective, the client would be reaching www.mystartup.com, and that would resolve to an IP address that is configured to the ELB, the Elastic Load Balancer, right? So when the user says go to www.mystartup.com, that traffic would go to this Elastic Load Balancer, right? Let me see if I have a better picture, probably. Yeah, so, okay. So yeah, let's use this, right? So you have a reverse proxy or a load balancer, and behind that you have two targets configured, right? The targets are the physical web servers that are running the same content here. So from the end user point of view, they would be going to www.mystartup.com, which would resolve to an IP address, and that IP address would be that would be configured on this load balancer. So when the traffic reaches here, the load balancer uses, there are multiple ways to send the traffic to the actual targets. It could be a simple route robin based, meaning every single request, it will try to send it to different unique servers, or you could use a sticky based algorithm. There are many different ways to achieve the load balancing as well, right? So I hope this sort of gives some clarity as to what a load balancer is. For Aru's question,
Yeah.
he was asking to in the benefit of others.
Yeah.
So we want to make sure that you all get that.
Yeah. So thanks, Muthu. Just to go back to Senthil's question, right? How when a new server gets added or an existing server gets removed, how does the load balancer or the Route 53 CNAME addresses that, whether a server is
Sure.
gone
Yeah. Okay.
or a new server is added. I think
Yeah.
there is a service called
Okay.
availability group or
I
target
think
groups.
scaling group, Aru. I think scaling group maintains that,
No.
so
Yeah,
IP address.
auto scaling
ASG,
group. Auto scaling group is one thing.
ASG auto scaling group that helps us to dynamically grow the targets, right? So up and down, depending on some policy that you institute, you can grow the number of targets. You can grow or shrink, right? So that's one thing, right? So the way Route 53 helps here is when you configure an address record for this elastic load balancer, right? So what you do is, when you configure a ELB, it will provide you with a name, as we saw in the previous screen here, right? So this is a domain name for a EC2 instance. Likewise, when you configure a ALB, you will be provided with a domain name. All you do is take that domain name, right, and configure an address record of type alias. So I will just go to this thing. You will not configure. I'll just show you. So you just simply do a create record.
Yeah, so
Right?
yeah, let me see if I can explain this quickly to others, Muthu. If we so basically everything, let's assume that everything that you create in AWS, your instances, then you set up a load balancer to proxy the user traffic to set up servers. The instances that's pointing the load balancer, the ELB service that you point, let's say www.ilakiam.org, right? That's your domain that you want the customer is accessing. So your load balancer proxying those, getting the user traffic and proxying to the whichever instances that available underneath the load balancer. So all this stuff, even your load balancer front end thing, it's just IP. So people needs to map this from their laptop. They need to know the IP address to reach this ilakiam.org website. So then how you can map the load balancer front IP to the website like a www.ilakiam.org. So that's where you need to bring in the Route 53 the DNS service, which can tie the load balancer IP address with the load balancer IP address, the front-end IP address with the host name www.ilakyam.org. So both are two different things. So the DNS it's a one service load balancer balancing the traffic. The DNS just giving the mapping, name to IP resolution mapping.
Right. I was going to, I think we kind of jumped a little far ahead. So we are going to be showing a demo. If people...
Muthu, so just to sake of this training, do you want anyone has a question, or we can jump back to the Route 53 services?
Yeah, we can go back to Route 53. I think it's clear, so we got it. Thanks.
Yeah, Muthu. So I think we don't want to go back.
No, the thing
explain
is,
the load balancer.
If people, no, actually, that's one of the use case. Actually, I wanted to show a demo. So that's why I have actually pre-configured couple of EC2 instances, right? So I was going to set up a load balancer, and I was going to put these two servers. I have one running in the AP South, and I have another instance running in US West. So this is exactly one of the scenario I was going to do a demo. So then what I was going to do is I was going to configure an ALB, application load balancer, and put these two devices behind those and use the ALB's domain name and register that in the ilakyam.org. Right. So I had this thing. So we can straight away jump there and we can see it. If people have good understanding of what this service is, right? Route 53, we can show the demo as well. We are nearing the top of the hour. So
okay.
Let me know however you guys want to do it. So
you have how many slides, Muthu, to cover on the 53?
I have quite a lot of slides. But again, let's see. So I have, we are on slide 13, I guess, right? So
yeah, if there is a key slides that you want to explain.
Yeah, okay. So
yeah, we don't have to go for every different types of record and stuff. Just explain the overall, then we can jump on to the practical.
So what we will do is I'll quickly spend like 2-3 minutes on the different routing policy that Route 53 DNS provides, and we'll quickly jump onto the demo, right? So simple routing is a policy whereby you have a resource that you want to be able to be accessed from the internet. You simply go and register or create an address record, right? So maybe I'll instead of I'll use this picture to explain, right? So let's say you have a web server running either in an AWS cloud or in your on-prem or anywhere, and let's assume that you're using a Route 53 as a DNS service. So all you would do is you would take the publicly routable IP address of this server and take it to the DNS service provided by Route 53, and you create an address record. And let's say you call it as a www.mystartup.com is the domain name. So you create an address record called www, and the end user, your customers, now would be able to use the domain name www.mystartup.com, and it will be routed to this. So that's a simple Route 53 DNS routing policy. Nothing fancy here. Every DNS providers provides the service. You can set up your own DNS server and you can provide this, right? So next is TTL based, right? So TTL based is, let's say, you have a simple Route 53 address record setup. As I said, every address record has this notion of TTL, or a time to live. It has an age. So let's say you have not set up a primary and secondary you're not using a failover based routing, which not a lot of DNS service provider provides. So let's say you have another server configured here ready to take over, okay, but you have to manually configure it, okay. So but it has a different IP address as well. So what you do is you have to wait for the time to live to expire, because the server doesn't control what is cached by the end user or the DNS resolvers in the internet, right? So you don't control that. So the concept of TTL is something that is assigned or mapped to the record that you create, and you don't have a direct control on that. Uh, After you configure, right, you can always go back and tweak that. I don't know, once you see an example, I think it will become a little clear. So basically all you're saying is, you have two resources or two servers. Server one is configured to be the one to be active, right? So you don't have active or a standby or a primary or a failover kind of a thing configured here. So this user would get the IP address mapped to this, but let's say if this server fails, right? If the server fails, unfortunately, this user would continue to access this server, because he already cached, he or she have already cached that mapping. So till the time ages out, it would try to reach that. So that's where the TTL would help. So if you have a shorter TTL configured, let's say by default, I think it will be 600 seconds or 300 seconds. But if you configure it, let's say for 5 seconds, right? So what happens is the first time it tries to query and gets the mapping, it caches only for 5 seconds. After 5 second elapses, that cache entry would be invalidated, and he has to go and get the mapping again. So the upside to that is, if a server failure happens, probably that is quickly taken care of it. By the next time it queries, it probably would get a different one if you happen to have another server, right? So if you configure it with a higher value of TTL, you will not be generating more DNS traffic, but you're prone to this kind of situation whereby the DNS server may fail, the server may fail, and the DNS resolver or your client may have to cache it for a longer duration. So let's say you have a primary and failover situation, and you configure health check and things like that. This is all taken care of it automatically. So that's the TTL based routing. So the alias and CNAME, we will see that with an example. It becomes a little clear.
Sorry to interrupt.
Yeah,
I think
sure.
we should have an advanced session where we can cover the little complex topics like TTL and other things. I'm not sure everybody is well versed with basic Route 53. Just my suggestion.
Okay.
It may be a little heavy dose when we talk about TTL. Um,
Okay. Fair enough. Fair enough. Okay.
yeah.
So I think, yeah. So if I don't know if the suggestion by Aru kind of makes sense to all of you. So I may not have done a good job of separating things out, like simple topics and little advanced topic in the DNS Route 53 service, right? So probably I think we should have stuck to some basics first, and you know uh, have a separate session to cover all the advanced topics of different routing schemes that Route 53 provides. I think that's what Aru's recommending. So we can have that. If folks are comfortable with the basics, we can uh, go through the slides to reinforce that concept, and we can table the advanced topics for some other day. So is the basic Route 53 or a DNS as a service, what it provides, is it a bit clear? We can have a demo for a simple DNS now, since we wanted to show Sham demo today, right? So is that
Yeah,
is that okay?
anyone have a question? What is Route 53 and how it helps?
Yeah, I'm good, but the demo would help.
Okay.
Okay.
So yeah, so that's good then. So let's do one thing. So I'll cancel this here. Okay. So now what we have done is we have a domain name already registered. Okay, so let's assume that we have already registered. The registration step itself is pretty straightforward. It will cost some money, so you have to be careful in case if you're trying to practice this on your own. Keep that in mind that if you try to register a domain, it will cost you like $12 to $15 a year. So here we don't have to do that because Aru already has a domain. He has registered that in AWS Route 53. So that's why you see in the Route 53 dashboard that we already have one domain registered already here, right? And each domain when you register should be mapped to what is called as a hosted zone. Hosted zone is nothing but a file, sort of a text file. If you configure DNS on your own, right, you would have to deal with what is called as a zone record. So the zone record is where you would have to configure all your mappings. Oh, this is my host name and this is the IP address and all those things. So each domain name is mapped to a hosted zone. Okay. So now I'm going to click the hosted zone. See the hosted zone, we have only one hosted zone here called ilakium.org that's mapped to that particular domain. Okay. So if you see, I have 4 different records. Okay. So the 4 different records, uh, by default, when you create a record, by default, when you create a zone, when you create a domain and when you create a zone, by the way, when you do it in AWS, right, the first 2 steps are automatically done for you. Meaning, when you register the domain, a zone file would be automatically created, and the zone file would be populated with 2 records automatically, the NS record and the SOA records. For now, I would say that, ignore these 2, because, it's a little bit, you need to know the big picture of, how DNS works, and, it's a little over the top in my opinion. So for a minute, assume that, these are very important, and you need to have these 2 records. These 2 are mandatory records. NS record, it's called name server record, and SOA stands for startup authority. Okay, for a minute, just ignore the big picture or the higher level details of this. So now you want to configure a web server. Okay, so as I said, I already have spun up a instance. It is in US West region. Okay, so I'll just close this so that you can see that. So what I'm going to do is I'm going to try and, this instance is already running. Okay, so now I'm going to try and open this using the IP address that this instance is configured with. This is a publicly routable IP address. Okay, I'm just trying to open that, and it's going to fail because by default it tries to go to TLS or SSL. So after I change it to HTTP, you can see that I'm able to connect to this web server, and it is running this public IP address. And as you can see, I try to connect that using this publicly routable IP address. Now what I will do is I will copy the publicly available domain name as well, right? I simply copied this. Okay. So you essentially you get the same, you're hitting the same server, 54, 215, 229, 17, right? You can see that. So now what we are going to do is we are going to take this IP address Okay, this publicly routable IP address. I'm going to create a record. Okay, address record. So I'm going to, as I said, there we briefly saw that there are different routing mechanism, DNS routing mechanism that Route 53 offers, but we are going to use simple routing. That's the default routing. Okay, so let's say demo DNS is the name that I want to give. Instead of www, I'm just giving a demo DNS. Okay, .ilakiam.org. So this is the full domain name, right, that we want to create in our Route 53 DNS service for this particular domain. And we want to be able to map it to this particular public IP address, right? So we'll see later on what an alias means. Okay, I'm not selecting this, right? And the record type, as I said, there are different kinds of record types, but right now we are focusing on of type address, which is an A record, right? This is to map a human readable domain name to an IP address. Okay, in case if you want to map it to an IPv6, you have to use what is called as a quad A record, right? If you want to set up a mail server, you would have to use MX record. So there are different types of record sets that you can create. Now just imagine a situation whereby you have to create a simple A record or an address record to map a human readable domain name to an IP address, right? Is this clear? This is the domain name that we are trying to create, mapping to this IP address, right? And before we do that, right? So let me do another, I'll show you one other thing. So I'm going to do a demo DNS dot
You mean dig?
KM. Yeah, I'm using this dig tool.
Dig.
Oh, sorry. Yeah. Sorry. Yeah. So dig is if you're familiar with NS lookup, right? So it's a similar tool to NS lookup, which you can use to do a lookup of equivalent IP address for a given domain name. So right now, it's not existent. So what I'm doing is I'm using dig to query the DNS server in the internet to find out, hey, what is IP address for this? So that is what is being sent as a question, right? In the question you can see, I'm querying for this domain name, right? I didn't get any answer because it doesn't exist, okay? So you can see the reply is NX domain. Whenever you receive an NX domain as an answer, right, it doesn't exist. So now I'll go create it, okay? So any questions on this, folks? As to what we are trying to do. It's a two-step things, two things we are trying to do. One is trying to query a domain name that doesn't exist now, or a, demo dns.ilakiam.org is a name that I'm
Yeah,
trying
you
to
can.
query.
Yeah, you can also use host NS lookup to make it easy. Muthu, the dig gives a lot of information. If you use it, that helps with the troubleshooting. But
Okay,
NS
so you're
lookup is
saying
very
you
simple.
use NS lookup, you're saying.
Yeah, that's very simple
okay.
for people
Yeah,
to
that's fine.
understand if it doesn't exist.
Okay.
Yeah, you see, server can't find that.
Yeah. So right now we don't have this record created. We don't have a record. At the same time, if you simply do for ilakiam.org, right, you will get a response. You get it, right? So we are getting a 52 to 17. I'll just show you. I'll open another window to show that mapping. So we already have a record for ilakiam.org that's configured. I think you have it in sale. Sorry, I kind of for a minute I forgot. So that's in a different server. Okay, so let's see if we can go to. I hope I'm not. Oops, EC, not EC2. I think, or you have it in some other account, I guess. So I'll probably just ignore it for now.
Yeah.
Okay.
So I think for now we can assume that that is the IP address
Yeah.
assigned, and we can move on.
Okay. Now I'm creating this record. Okay. So we have created a fifth record now. So that record is for demo DNS ilakiam.org. Okay. Now what we will do is we'll simply do the same NS lookup. Okay, you can see that now you're getting an authoritative, non-authoritative answer, but nevertheless you are getting an answer. This is the record that we just created. If you can see that 54, 215, 229.17. Now, more importantly, if I simply take this domain name now, right, and try to, you can actually try this as well, and I'll just put it in the chat window. So what we did is, where is the chat window? Is it Q&A?
So it gets populated pretty soon, within a second.
Yeah, it's instantaneous, right? So yeah, so now I don't know if how do I,
The chat.
yeah, I don't use Zoom that much, so just bear
Okay,
with
I
me.
can put it in the chat.
Oh, you can. Okay, thank you.
Demo. Yeah, I'll put it.
Yeah, demo-dns.ilakiam.org. So folks, all we did is, we have a pre-registered domain, right? In the pre-registered domain, we just created an address record, demo-DNS, and we mapped it to a web server that we have running in a AWS. Right. So this is kind of similar to what Kanak was saying earlier, except that we kind of short-circuited some of those steps. The registration, domain name registration. Let's say you have a startup, you have to do the domain name registration, and then you have to set up a web server. Then you have to somehow register the web server name to your domain name system. We kind of short-circuited that, and we are using a pre-existing domain name, and we have a web server that is running. We took the IP address of that, and we simply created an address record, and boom, you have a DNS name for your web server now. So this is nothing but the same web server that we access through the public IP address first, and second, we use this domain name that AWS provides that's resolvable to AWS a domain name for this public instance. Then what we did is we went further one step, and we mapped the same IP address to a domain name that we own, in this case Aru owns, and we created a record, demo DNS.
Yeah, people will not know whether it's hosted in AWS or Google or Azure
Exactly.
or whatever. Yeah, so
Exactly.
this is your own domain now. So
Folks,
let's check if anybody has a question, Muthu. So we are on top of the hour.
Okay, very good. Okay, so folks, any questions? So the dig, I hate to going back to dig again. Dig provides more information. As Kanak said, it could be a double-edged sword. It could be confusing as well. You can see that query time, it took 48 milliseconds to get an answer, and it gives you a separate question and answer sections, and all those things. Now you get a no error, right? So all those things. So if there are no questions, let me quickly go to the slide deck, and we will wrap up for today, and we will table the other sections for some other day.
Muthu, just to make sure people are awake, on quick question, on trivia question.
Sure, please.
Route 53. Why the number 53 is there in Route 53? And Route 53 is a DNS service. What
Because
is the
it uses
significance
port
of
50.
number 53?
Why it's not 51?
Yeah.
Yeah, we kind of touched upon it in one of the slides. So hopefully just a clue for people.
Yeah, it uses the port 53.
That's it. Yeah, DNS service uses UDP port 53. Yeah. Yeah. And i- see the logo, right? You know, if you guys see, it kind of borrows the logo from Route 66. So this Route 66 is a very popular route in the olden days, I guess. And Aru, if you want to shed more light as to
No,
for
I
the
just want
trivia.
to keep it interactive and see people are awake.
Yeah,
Can
that's
we
a good one.
register? Can we buy or register domains in AWS Route 53 service? So you want to buy yourname.com. Can you buy it using AWS account?
It does, right? Because Muthu said they offer
Exactly.
the domain registration. So
Exactly. Yep. Yeah,
they also
you're right.
offer. Yeah.
You're
Yeah.
right. So if you go to the console, right? So you just click get started, right? You see there are plenty of options. You can register a domain as well. So AWS being a registrar, you can actually register a domain. So I won't do it. I won't do the thing. I'll just show you guys. You can just say Muthuraja Ayyanar. Okay, let's say if I want to do this, I can check to see if it's available or not. It says it's available. I can add to the cart and bill Aru. So, but I won't do it. But thanks, Aru. I think this is a good one. I think, yeah, I have it in the slides, but unfortunately, we kind of,
Yeah.
we didn't have time to go through all of them. So if you see this slide, right? So I was just going to go through the process of, how to register a domain and how to get in all those things. But we kind of
Yeah.
jumped
Later
around a
we
little
can
bit.
also
And
at the advanced level we can show how to host your site in S3 service, static website. In fact, ilakim.org itself is hosted on S3 as a static website. So that is one
good
thing
point.
we can cover in
Yep.
future.
Yeah, I was going to show that in the use cases, right? For the alias use cases, I was going to use, because we are essentially using a alias record, right? So if you simply select this, right? So if you simply look at it, we are using a alias record. So certainly we can cover that as well in the next session or in the advanced session.
Yeah. One quick announcement. So a lot of friends are here. This is knowledge sharing for the community. So Muthu has volunteered and he has given, I think now 5 or 6 sessions on various topics. I have also given around 7 or 8 sessions in the past, and Kanak has also come forward to provide more knowledge sharing sessions on hybrid cloud. And if any of you think you have some topic to share, please let us know. You can present, and it is a win-win. You will also improve your presentation skills, and also the community will benefit out of it. So if you have anything to share, you can share anything that is beneficial to people. So please come forward. Thanks.
It doesn't have to be AWS, right?
Doesn't have to
Anything.
be AWS. It
Yeah.
can be,
Even the
can be,
Azure or whatever. Even some Python, whatever.
yeah.
Certainly. Thank you. Thank you, Arun Kanan. Yeah, appreciate it. Yeah. So I'm just shutting down. I just already shut down a couple of instances, or I created in ilakiam.org. I think I just shut the one that I created on my account. So hopefully I'll make sure I clean up anything that I used on ilakiam.org.
Aru, this Ganpa, actually this AWS is going to be a going to be a continuation next week also, or it's
Yeah, so this will be a continuous session. So next week, probably we will cover more advanced topics on AWS. And meantime, if you want any topic or if you can present a topic, please come forward. And we will also share the recordings of past sessions as well, along with the slides. So you can go back and refer to those.
thanks, Aru and Muthu.
Thank you, everybody. Thank you. Yeah, certainly.
Thank you very much. Appreciate it.
Hello. Thank you, folks.
Thank you, Aru, Muthu, I think Kanak and friends. Yeah.
Thank you, Aran.
Yeah.
Thank you. Thank you. Aru, do you have a minute now?
Yeah.
Okay. I just wanted to, all the sessions, right? I'll put up, I just want to make sure you have access to this particular Google Drive. I can put all the PDFs there. Or if you have a Google Drive, if you can let me know, I can just upload all the PDFs there of all the sessions that we covered in the past, right?
The
So
slides you are saying, Muthu?
Yeah, slides, yeah.
Yeah, I think that will be useful. Yeah.
So there is a shared Google Drive under American Tamil Media, the tamilmedia.org. So if you keep it there, it will become a good archival.
Is it the ATM Academy, this one, Naru? I want to make sure.
Yeah, correct.
Okay, I can just simply put all the PDFs here?
Yes, we can. You can put slides or PDFs, but it's better to share the PDF when we share it with the people.
Right. I can, but
I will make sure you have the privilege here to
okay.
dump
Yeah, please. Yeah, if you can let me know if I can upload that. I can actually. These are the different contents I have: VPC, Route53 KMS, ELB. I think we didn't cover EBS, EFS. I didn't do it, but I can actually.
another?
KMS, the key management service we did.
Oh,
right?
okay, yeah. We covered one time.
And also we discussed a bit on certification, AWS Solutions Architect Associate Certification process. So if any of you are interested in preparing for that, you can also prepare as well as share. So that way you will prepare more.
Yeah,
okay.
certainly.
Or someone,
all these.
Shivakumar, I think Shivakumar Ramasamy, somebody looks like they have a question. Shivakumar, you have a question?
Yeah. Are you able to hear me?
Sure.
Yes.
Yep.
Okay. So basically, I am not a very network, I know I have studied computer networks. I know there is 7 layers in the OSI layer. But it's been a long time. We haven't refreshed networks at all because we are just application programmers. We never worked on, but coming to AWS infrastructure, we need to understand all these network basics. So is there going to be is it going to be just a question, do we need to refresh the network basics before we get into these kind of sessions? It's one thought. And then I also have another follow-up question once you finish this. That is completely different. The second question is, a lot of people are now, AWS is promoting developer, I think like adoption. So I see that everywhere. Even I'm from Dallas, but Dallas also has a lot of meetups and all these things related to AWS. So how is it like, is it Google Cloud versus AWS versus, because we are confused as application developers, which one we should, Microsoft Azure, so we are so confused in this cloud. So I think AWS has taken a lead, but what should we do as a developer to migrate? I know we are trying AWS here, but then I want your thoughts on other cloud providers too, and which one is suitable for who. So that is something that I would like to know, so that I don't end up in an ecosystem where I cannot sustain.
Yeah, that's a great question. I also had the same question like 3-4 years back when I was preparing for the certification. I was wondering whether I'm going in the right track or not. So I would say there are two things you should look at here, Sivakumar. One is, who is the market leader, and where is the demand, right? Which cloud has more demand? That is one thing. And the other one is um, what your company is using right now, or where your company is heading to. So these two things actually will give you some good idea about where you can land. So to answer the first part, who is the market leader? It is a very clear answer that AWS has the lead on the market. And the job demand, if you see, it is way high on AWS, especially on the solution architecture area and also on the development side. It is a bigger ecosystem, followed by Azure, and then followed by Google and Oracle, Alibaba and others. So if you think about the database ecosystem like 20 years back, when we say relational database, everybody by default was learning Oracle, and that's how I see AWS being the market leader when it comes to public cloud. And then when you learn AWS cloud, that's what happened to me. At least my company said we are not moving into AWS cloud, because my company that time where I was working looked at AWS as a competitor for them in the retail business, on the grocery and other things. So they said we are moving to a different cloud. So in that case, I really felt I did a certification which I cannot use in my current job. Then I had to quit that job voluntarily and then look for my next job. But that may not be the right thing to do always for everyone. So you also should learn what your company is heading into. If your company is heading into ABC cloud, then you should learn ABC cloud. At the same time, keep an eye on the market leader. That is always important. So knowing a multi-cloud is even better. You can compare and contrast things, which will help the companies also, make right decision. You can recommend the companies to make the right decisions. That's how I look at it. Anybody else?
I think that's a very uh, good point. But what other thing is, I think Ari kind of mentioned that as well. So if you learn AWS, pretty much I think most of the other uh, service like what Azure is providing, they're taking a leaf out of what AWS is doing. And if you know AWS, pretty much you can survive, and you can in fact not only survive, thrive in other cloud providers, right? So if you know the concepts here, you can easily apply those learnings and be a superstar there in other, in case if your company adopts today AWS and tomorrow if they go to GCP or Azure, you can, it's not going to go waste, I guess. So, right?
I'll stop the recording here since we are done with the core presentation part.
Okay.